Division. Meaning of division. Division means repeated subtraction. Let us consider an example. Look at the picture given here. In all, here there are 10 objects. If we divide them into groups of 2 objects each, we get 5 such groups of 2 objects each. First, take away a group of 2 objects from the total of 10 objects. Thus, we can say that 8 objects are remaining. This means that there are 4 groups of 2 objects each left with us. Now again, for the second time, take away one more group of 2 objects. Thus now, 6 objects are remaining. This means now there are 3 groups of 2 objects remaining. Let's take away one more group of 2 objects for the third time. Thus, we are left with 4 objects now. This means 2 groups of 2 objects are left. Now, for the fourth time, again remove 2 more objects from the remaining 4 objects. After that, only 2 objects, that is, only one group is remaining. Now, for the fifth time, remove again a group of 2 objects. At this time, you will have no objects remaining, or we can say 0 objects are remaining. Thus, when we remove a group of 2 objects at a time from a group of 10, we get 5 such groups of 2 each. Here, what we have done is, we have subtracted 2 from 10 5 times. That is, 10 minus 2 is equal to 8. 8 minus 2 is equal to 6. 6 minus 2 is equal to 4. 4 minus 2 is equal to 2. And 2 minus 2 is equal to 0. This means if we subtract 2 from 10 5 times, we get 0. Or we can say that 10 divided by 2 equals to 5. Written form is as shown. The sign for division is as shown. Division means equal distribution. Look at this example. In all, there are 10 apples. Now, we are going to divide these 10 apples among 5 persons. So, let's first distribute 1 apple each. So, 5 apples are given and 5 apples are left out. Again, give 1 apple to each person. Now, all the apples are given and no apples are left out. So we can say that each person got 2 apples. From this, we can understand that when 10 apples are distributed to 5 persons, each person will get 2 apples. This means 10 divided by 5 is equal to 2. As each and every person got equal number of apples, from this we can understand that division means equal distribution. Let us see one more example. Divide 12 bananas into 4 equal parts. How many bananas will there be in each part? Totally, there are 12 bananas. First, distribute 1 to each of the 4 groups. Distribute 1 more to each of 4 groups. Again distribute 1 more to each of 4 groups. Now, no bananas are left out. Thus, we can see there are 3 bananas in 4 groups. This means that when the total number of bananas, that is 12, is divided by 4, that is the number of parts, we get 3 bananas in each part. In short, 12 divided by 4 equals 3. Using tables for division. Look at the picture. There are 3 flowers in one bunch, and there are 5 such bunches. If we combine all these 5 bunches, we get 3 multiplied by 5, which is equal to 15 flowers. Here, the operation involved is multiplication. Division is exactly the opposite of multiplication. Division is exactly the opposite of multiplication. Now, we do the same process in the reverse order. Look at this picture. Here we have a bunch of 15 flowers. Say, we have to make a bunch of 3 flowers each. Now, let's see how many bunches can be made of 3 flowers each from 15 flowers. When you will make the bunches of 3 flowers each, you will see that there can be 5 such bunches made. This means that we have divided 15 flowers into bunches of 3 flowers each and have got 5 such bunches. In short, we can say that 15 divided by 3 is equal to 5. Now let's see both multiplication and division together. From this, we can say that 3 multiplied by 5 is equal to 15, and 15 divided by 3 is equal to 5. 15 divided by 3 is equal to 5 means when we say 3 times table, that is 3 ones are 3, 3 twos are 6, 3 threes are 9, 3 fours are 12, 3 fives are 15. We come across 3 fives are 15. Thus we get 15 divided by 3 is equal to 5. In this way, we can do division by using multiplication table. Now, let us solve some examples by using multiplication table without taking objects. 28 divided by 7. To get the answer for this, we have to say 7 times table up to 28. We know that 7 fours are 28. Hence, 28 divided by 7 is equal to 4. Let us take one more example. 54 divided by 9. To carry out the division, 54 divided by 9, we have to say the 9 times table till 54. We know that 9 sixes are 54. Hence, 54 divided by 9 is equal to 6. Let us now solve the exercise from page number 54. Question 1. Fill in the boxes. 1. To carry out 30 divided by 5, say the 5 times table up to 30. 2. To carry out 36 divided by 4, say the 4 times table up to 36. 3. To carry out 78 divided by 13, say the 13 times table up to 78. 4. to carry out 54 divided by 6, say the 6 times table up to 54. 5. To carry out 119 divided by 17, say the 17 times table up to 119. Question 2. Fill in the boxes. 1. 7 nines are 63. Hence, 63 divided by 7 is equal to 9. 2. 6 threes are 18. Hence, 18 divided by dash is equal to 3. Since 6 times table is used here, we get 18 divided by 6 is equal to 3. 3. 3 sixes are 18. Hence, 18 divided by dash is equal to 6. Here, we use 3 times table. Therefore, 18 divided by 3 is equal to 6. 4. 11 sixes are 66. Hence, dash divided by 11 is equal to dash. Here, we use 11 times table till we get 66. So, in the first dash, we write 66 and second dash, we write 6. This means 66 divided by 11 is equal to 6. 5. 15 fours are 60. Hence, 60 divided by 15 is equal to dash. Here, in 15 times table, we get 15 multiplied by 4 is equal to 60. This means 60 divided by 15 is 4. 6. 13 eighths are 104. Hence, 104 divided by dash is equal to 8. Here, 13 multiplied by 8 is equal to 104. Therefore, 104 divided by 13 is equal to 8. Question 3. Divide with the help of tables. Write the answer in the box. 1. 21 divided by 3 is equal to dash. Here, we use 3 times table till we get 21. 3 multiplied by 7 is equal to 21. Hence, 21 divided by 3 is equal to 7. 2. 20 divided by 5 is equal to dash. By using 5 times table up to 20, we get 5 multiplied by 4 is equal to 20. Hence, 20 divided by 5 is equal to 4. 3. 24 divided by 4 is equal to dash. 4 multiplied by 6 is equal to 24. Hence, 24 divided by 4 is equal to 6. 4. 42 divided by 6 is equal to dash. 6 multiplied by 7 is equal to 42. Hence, 42 divided by 6 is equal to 7. 5. 27 divided by 9 is equal to dash. 9 multiplied by 3 is equal to 27. Hence, 27 divided by 9 is equal to 3. 6. 49 divided by 7 is equal to dash. 7 multiplied by 7 is equal to 49. Hence, 49 divided by 7 is equal to 7. 7. 16 divided by 2 is equal to dash. 2 multiplied by 8 is equal to 16. Hence, 16 divided by 2 is equal to 8. 8. 32 divided by 8 is equal to dash. 8 multiplied by 4 is equal to 32. Hence, 32 divided by 8 is equal to 4. 9. 36 divided by 6 is equal to dash. 6 multiplied by 6 is equal to 36. Hence, 36 divided by 6 is equal to 6. 10. 45 divided by 5 is equal to dash. 5 multiplied by 9 is equal to 45. Hence, 45 divided by 5 is equal to 9. The division operation. First, let us learn how to divide a one-digit number by another one-digit number by using the division operation. Look at this example. Let us find out how much is 8 divided by 2. You know that 8 divided by 2 is written as the number to be divided is known as the dividend. Here, we have to divide the number 8. Hence, the dividend is 8. The number by which we divide is known as the divisor. Here, we divide the number 8 by 2. Hence, the divisor is 2. We also know that we get the answer to 8 divided by 2 means by saying 2 times table up to 8. As 2, 4 are 8, hence we write 4 above the line. This 4 is known as our quotient. After that, we write the product 8 below the dividend 8. Now, let's subtract the product 8 from the given dividend 8. As 8 minus 8 is equal to 0, this 0 is known as our remainder. Hence, 8 divided by 2 is equal to 4. Thus, here we get dividend is 8, divisor is 2, quotient is 4, and the remainder is 0. Let us solve another example. 15 divided by 4. 15 divided by 4 is written as, here we have to divide 15 by 4. Hence, we say 4 times table up to 15. We know that 4 3s are 12 and 4 4s are 16. As 15 lies between 12 and 16, we have to stop saying the tables here. 16 is bigger than 15. So, we consider 4 3s are 12. Hence, we write 3 above the line, which becomes our quotient, and the product 12 below 15. Now, we subtract the product 12 from the dividend 15. We know that 15 minus 12 is equal to 3. Therefore, we get the remainder as 3. Thus, in this sum, our dividend is 15, divisor is 4, quotient is 3, and remainder is also 3. We will now solve a few examples from the exercise. Question 1. Divide with the help of tables. 28 divided by 7. Here, we have to divide 28 by 7. We know that by saying 7 times table, we get 7 fours are 28. Hence, write 4 above the line, which becomes our quotient, and write 28 below the dividend 28. Now, subtract the product 28 from the dividend 28, as 28 minus 28 is equal to 0. Therefore, 0 becomes our remainder. Thus here, our dividend is 28, divisor is 7, quotient is 4, and remainder is 0. Next question is 35 divided by 5. Here, since the divisor is 5, we have to say 5 times table up to 35. As 5 sevens are 35, we write 7 as the quotient, that is above the line, and the product 35 below the dividend 35. Now, we subtract the product 35 from the dividend 35, as 35 minus 35 is equal to 0. 0 becomes our remainder. Thus here, our dividend is 35, divisor is 5, quotient is 7, and remainder is 0. Next, we will divide 81 by 9. Here, the divisor is 9. Therefore, we have to say 9 times table till we get 81. We know that 9 nines are 81. Hence, write 9 as the quotient and write 81 below the dividend 81. Now, subtract 81 from 81. We get that 81 minus 81 is 0. So, we write 0 as the remainder. Thus here, our dividend is 81. Divisor is 9. Quotient is 9 and remainder is 0. Question 2. Find out the dividend, divisor, quotient and remainder. 19 is divided by 3. Here, dividend is 19, divisor is 3, remainder is 1 and the quotient is 6. 10 is divided by 2. Quotient is 5, remainder is 0, dividend is 10 and the divisor is 2. Till now, we have learnt how to divide a 2-digit number by a 1-digit number, where we have got the quotient as a 1-digit number. Now, we are going to learn how to divide a 2-digit number where the quotient we get is also a 2-digit number. Let us consider an example, 64 divided by 2. Here, when we say 2 times table, we find difficult to get 64. Hence, we have to follow a different type of method for solving such problems. Here, the dividend is 64. That is, the digit in the tens place is 6 and the digit in the units place is 4. First, we take the number on the left of 64. That is 6. The divisor is 2. Say 2 times table up to 6. As 2 3s are 6, we will write 3 above 6 in the tens place of the quotient. Now, write the product 6 below 6. Subtract the product 6 from 6 tenths. We get the remainder as 0 tenths. Now, bring the 4 units down and write next to the remainder 0. Thus, now we have to divide 4 units by 2. Again, say the 2 times table up to 4. As 2 2s are 4, therefore, we will write this 2 in the quotient next to 3. Write the product 4 below 4. Subtract the product 4 from 4 units. The remainder we get is 0. Thus, the quotient is 32. Hence, 64 divided by 2 is equal to 32. Thus, the dividend is 64, divisor is 2, quotient is 32, and the remainder is 0. Let us now solve a few examples from the exercise. 63 divided by 3. Here, the dividend is 63. This means 6 tenths and 3 units. The divisor is 3. First, we have to divide 6 tenths by 3. As 3 2s are 6, we will write 2 in the tens place of the quotient. Now, write the product 6 below 6 tenths. Subtract 6 minus 6, which is equal to 0. So, the remainder in the tens place is 0. Now, bring 3 units down and write it in front of the remainder 0. We know that 3 ones are 3. So, the quotient is 1, which we will write next to 2 in the quotient, that is, in the units place of the quotient, and 3 below 3. As 3 minus 3 is equal to 0, we get the remainder of this sum as 0. Thus, the quotient is 21. Hence, 63 divided by 3 is equal to 21. Thus, the dividend is 63. Divisor is 3. Quotient is 21 and the remainder is 0. Let us solve one more sum. 55 divided by 5. In 55, there are 5 tenths and 5 units. The divisor is also 5. So, let's begin with the sum. First, we will divide 5 tenths by 5. As 5 ones are 5, we will write 1 in the tens place of the quotient and the product 5 below 5 tenths. Now, subtract 5 minus 5, which is equal to 0. Further, bring 5 units down and write it in front of 0. Again, 5 ones are 5. So, write 1 in the units place of the quotient and the product 5 below 5. Again, we get 5 minus 5 is equal to 0. Hence, we get the remainder as 0 and the quotient as 11. Thus, 55 divided by 5 is equal to 11. Thus, the dividend is 55. Divisor is 5. Quotient is 11 and the remainder is 0. Now, look at this example. 36 divided by 4. We have already done this sum as follows. Here, the divisor is 4. Hence, by saying 4 times table up to 36, we get 4 9s are 36. So, we know that 36 divided by 4 is equal to 9. But, here we will learn how to do the sum by considering one digit at a time. In the number 36, the digit in the tens place is 3 and in the units place is 6. First we have to divide 3 by 4, but as 3 is smaller than 4, we cannot divide 3 by 4. So, we will write 0 in the tens place of the quotient and the product of 0 and 4, that is 0 below 3. After subtracting 0 from 3, we get our remainder as 3. Now we shall bring the units number, that is 6, down and write it next to 3. So, we have to divide the number 36 by 4. As 4 nines are 36, we will write 9 in the units place of the quotient and the product 36 below 36. Subtract 36 minus 36. The remainder is 0. Hence, the quotient is 9 and the remainder is 0. Thus, the dividend is 36, divisor is 4, quotient is 9 and the remainder is 0. We will now solve a few examples from the exercise. 54 divided by 9. In the number 54, first we have to divide 5 tens by 9. But 5 is smaller than 9. So we will write 0 in the tens place of the quotient and the product of 0 and 9, that is 0 below 5. After subtracting 0 from 5, we get our remainder as 5. Now, we shall bring the units number, that is 4, down and write it next to 5. Thus now, we have to divide 54 by 9. We know that 9 sixes are 54. So we will write 6 in the units place of the quotient and write the product 54 below 54. As 54 minus 54 is equal to 0, we get our remainder as 0. Hence, the quotient is 6 and the remainder is 0. Thus, the dividend is 54, divisor is 9, quotient is 6 and the remainder is 0. Let us solve one more problem. 60 divided by 2. Here, first we have to divide 6 tens by 2. As 2 threes are 6, we will write 3 in the tens place of the quotient and 6 below 6. Subtract 6 minus 6, which is equal to 0. Now bring 0 units down and write it in front of the remainder 0. As 2 zeros are 0, we will write 0 in the units place of the quotient and 0 below 0. Subtract 0 minus 0, which is equal to 0. Hence, we get the quotient as 30 and the remainder is 0. Thus, the dividend is 60, divisor is 2, quotient is 30 and the remainder is 0. Now look at this example. 57 divided by 3. Here too, we follow the same procedure. But the only difference here is, after dividing the tens digit, instead of getting 0 as the remainder, we will get some other number. Let's now actually see how can we solve this sum. First, divide 5 tens by 3. When we say the 3 times table, we know that 3 ones are 3 and 3 twos are 6. As 3 twos are 6 is greater than 5, which is a part, our dividend, we will consider 3 ones and 3. Hence, we will write 1 in the tens place of the quotient and write the product 3 below 5. Now, we will subtract the product 3 from 5. The remainder is 2. Now, bring the unit number 7 down and write it in front of 2. Thus now, we get the number 27, which has to be divided by 3. By saying 3 times table, we get 3 nines are 27. So, we will write 9 in the units place of the quotient and write the product 27 below 27. As 27 minus 27 is equal to 0, we get our remainder as 0. Hence, the quotient is 19 and the remainder is 0. Thus, the dividend is 57, divisor is 3, quotient is 19 and the remainder is 0. Let us now solve a few examples from the exercise on page number 59. Divide 68 by 4. First divide 6 tenths by 4. When we say the table of 4, we come across 4 ones are 4 and 4 twos are 8. As 8 is bigger than 6, we will consider 4 ones are 4. Hence, we will write 1 in the tens place of the quotient and 4 below 6. After subtracting 4 from 6, we get 2. Now, we will bring 8 from the unit part of our dividend down and write it in front of 2. Thus, now we have to divide 28 by 4. As 4 sevens are 28, we will write 7 in the units place of the quotient and 28 below 28. As 28 minus 28 is equal to 0, we get our remainder as 0. Hence, the quotient is 17 and the remainder is 0. Thus, the dividend is 68, divisor is 4, quotient is 17 and the remainder is 0. Let us solve one more example. Divide 59 by 7. As 5 is smaller than 7, we will write 0 in the tens place of the quotient and also 0 below 5. We get 5 after subtracting 5 minus 0. Now write 9 in front of 5. As we know that 7 eighths are 56 and 7 nines are 63. 63 is bigger than 59. So, we will write 8 in the units place of the quotient and 56 below 59. After subtracting 56 from 59, we get our remainder as 3. Hence, the quotient is 8 and the remainder is 3. Thus, the dividend is 59, divisor is 7, quotient is 8 and the remainder is 3. We will now learn how to divide a 3-digit number by a 1-digit number. Here too, we are going to follow the same procedure. The only difference here is one more digit is added, that is, in the hundredths place. Let us solve an example 494 divided by 4. Here, first we have to divide the hundredths number, then the tens, and then the units number. The divisor in this sum is 4. So, we have to use the 4 times table. The digit in the hundredths place is 4. As 4 ones are 4, we will write 1 in the hundredths place of the quotient. Subtract the product 4 from the dividend 4. That is, 4 minus 4 is equal to 0. Now, bring 9 from the tens place of the dividend down and write it in front of 0. Thus, now we have to divide 9 by 4. As 4 twos are 8 and 4 threes are 12, we will consider 4 twos are 8 as 12 becomes a bigger number than 9. Therefore, we will write 2 in the tens place of the quotient and 8 below 9. Now, subtract 8 from 9. That is, 9 minus 8 is equal to 1. Now, bring 4 from the units place of the dividend down and write it in front of 1. Again, here as 4 3s are 12 and 4 4s are 16, we will consider 4 3s are 12 as 16 is bigger than 14. Hence, we write 3 in the units place of the quotient and 12 below 14. Subtracting 12 from 14, we get 2, which becomes our remainder. Hence, the quotient is 123 and the remainder is 2. Thus, the dividend is 494. Divisor is 4. Quotient is 123 and the remainder is 2. Let us now solve a few examples from the exercise. Question 1. 733 divided by 6. Here, the divisor is 6. So, we have to use 6 times table. First, we have to divide the digit in the hundredths place, that is 7 by 6. As 6 ones are 6 and 6 twos are 12, we will consider 6 ones are 6 because 12 is bigger than 7. Hence, we will write 1 in the hundredths place of the quotient. Now, subtracting 6 from 7, we get 1. Now, bring 3 from the tens place of the dividend down and write it in front of 1. Thus now, we have to divide 13 by 6. As 6 twos are 12 and 6 threes are 18, we will consider 6 twos are 12 because 18 is bigger than 13. Hence, we will write 2 in the tens place of the quotient. Subtracting 12 from 13, we get 1. Now, bring 3 from the units place of the dividend down and write it in front of 1. Now, we have to divide 13 by 6. Again, 6 twos are 12. Therefore, subtracting 12 from 13, we get 1. Thus, when we divide 733 by 6, we get the quotient as 122 and the remainder as 1. Thus, the dividend is 733, divisor is 6, quotient is 122 and the remainder is 1. Question 2. 976 divided by 8. Here, the divisor is 8. Hence, we have to use the 8 times table. First, we have to divide the digit in the hundredths place, that is 9 by 8. As 8 ones are 8 and 8 twos are 16, we will consider 8 ones are 8 because 16 is bigger than 9. Hence, we will write 1 in the hundredths place of the quotient. Now, we will subtract 8 from 9. That is, 9 minus 8 is equal to 1. Now bring 7 from the tens place of the dividend down and write it in front of 1. Thus, now we have to divide 17 by 8. As 8 twos are 16 and 8 threes are 24, we will consider 8 twos are 16 because 24 is bigger than 17. Hence, we will write 2 in the tens place of the quotient. Subtracting 16 from 17, we get 1. Now, bring 6 from the units place of the dividend down and write it in front of 1. Thus now, we have to divide 16 by 2. As 8 twos are 16, we will write 2 in the units place of the quotient and 16 below 16. After subtracting 16 from 16, we get 0, which becomes our remainder. Therefore, the quotient is 122 and the remainder is 0. Thus, the dividend is 976, divisor is 8, quotient is 122 and the remainder is 0. Now, Look at this example. 412 divided by 4. Dividing the 4 in the hundredths place by 4, we get the quotient is 1. Therefore, we will write 1 in the hundredths place of the quotient and 4 below 4. Now, 4 minus 4 is equal to 0. After that, we will bring down 1 of the tens place and write it in front of 0. That is, now we have to divide 1 by 4. Here, the dividend 1 is less than the divisor 4. As 4 zeros are 0, the quotient will be 0 in the tens place. Therefore, we will write 0 in the tens place of the quotient and 0 below 1. Now, subtracting 0 from 1, we get 1. After that, we will bring down 2 from the units place of the dividend and write it in front of 1. Thus, now we have to divide 12 by 4. As 4 threes are 12, we get our quotient as 3 in the units place. Therefore, we will write 3 in the units place of the quotient and 12 below 12. Now, 12 minus 12 is equal to 0. Hence, when we divide 412 by 4, we get the quotient as 103 and the remainder as 0. Thus, the dividend is 412, divisor is 4, quotient is 103 and the remainder is 0. Students, here you can notice that when the digit in the tens place, that is 1 was brought down, we got the dividend 1, which is less than the divisor 4. So, we wrote 0 in the quotient and then proceeded with the next steps. Let us now solve some examples of this type from the exercise given on page number 61. 714 divided by 7. Here, the divisor is 7. First, dividing 7 in the hundredths place by 7, we get the quotient as 1 in the hundredths place. Therefore, we will write 1 in the hundredths place of the quotient and 7 below 7. Subtracting 7 minus 7, we get 0, which is our remainder. Now, bring down 1 from the tens place of the dividend and write it in front of 0. That is, now we have to divide 1 by 7. As 1 is less than 7, we will write 0 in the tens place of our quotient as well as below 1. After subtracting 0 from 1, we get our remainder as 1. Now, bring down 4 from the units place of our dividend and write it in front of 1. Thus now, we have to divide 14 by 7. As 7 twos are 14, we will write 2 in the units place of the quotient and 14 below 14. After subtracting 14 from 14, we get our remainder as 0. Hence, the quotient is 102 and the remainder is 0. Thus, the dividend is 714, divisor is 7, quotient is 102 and the remainder is 0.
The dividend 42 is written inside the symbol bracket and divisor 2 is written outside the bracket. Now, while beginning to divide 42 by 2, going by the rules, we will consider the digit on the extreme left of the dividend 42, that is 4. We have to divide 4 into 2 equal parts, that is, recollect the tables of 2. Do 4 occur in the table of 2? Yes. 2 into 2 is equal to 4. So write 2 above the line and write the product 4 below the digit 4. Show the arrows, that is, 2 into 2 is equal to 4. Subtract 4 minus 4 is equal to 0. Now, bring the next digit in the dividend, that is 2, next to 0. Again, recollect the tables of 2. We now have to divide 2 into 2 equal parts. 2 into 1 is equal to 2. So, write the digit 1 next to digit 2 above the line and product 2 below the number 2 as shown. Subtract 2 is equal to 0. Here, 0 is the remainder. When the remainder is obtained as 0, it means we should stop dividing. The answer obtained above the line after dividing 42 by 2, that is 21, is the quotient. Thus, 42 is the dividend, 2 is the divisor, 21 is the quotient, 0 is the remainder. Thus, answer is 42 divided by 2 is equal to 21. Let us consider another example of division. Divide 59 by 7. Solution. 59 have to be divided into 7 equal parts. 59 is the dividend and 7 is the divisor. Place the numbers as shown considering the digit to the extreme of the dividend 59, that is 5. 5 cannot be divided by 7, so we will consider both digits 59 together. Recollect table of 7. As we know, 7 into 8 is equal to 56. 7 into 9 is equal to 63. Now, 56 is less than dividend 59 and 63 is greater than the dividend 59. So we will have to consider the lesser product, that is 56. So considering 7 into 8 is equal to 56. Now, dividing 59 by 7, we should write 8 above the line and 56 below 59 with a subtraction sign to the left. 59 minus 56 is equal to 3. Now, we cannot divide 3 by 7 and we do not have any digits after 9 in 59. So, 3 is considered as the remainder and the quotient is 8. Therefore, answer is when 5 is divided by 7, quotient is equal to 8 and remainder is equal to 3. Now let us learn how to divide a 2-digit number by a 2-digit number. Let us take an example from exercise 54. Question. Divide. Solution. Here, the dividend is 98. Divisor is 14. Let us arrange the division vertically. Let us consider the digit on the extreme left of the number 98, that is 9. 9 cannot be divided into 14 equal parts, that is, we cannot divide 9 by 14. Hence, write 0 above 9 in the quotient's place. Now, 9 minus 0 is equal to 9. Next, we write 8 in front of 9. Now, let us divide 98 into 14 equal parts. Recollect the table of 14 for this. 14 into 6 is equal to 84 and 14 into 7 is equal to 98. Thus, we can directly write 7 above the line in quotient's place and 98 minus 98 is equal to 0. Therefore, answer is when 98 is divided by 14, quotient is equal to 7, remainder is equal to 0. Let us now take an example from exercise 55. Question. Divide. 2. Divide 74 by 36. Solution. Here, the dividend is 74 Divisor is 36. We have to divide 74 into 36 equal parts. Consider the digit to the extreme left of the dividend 74, that is 7. We cannot divide 7 by 36. So write 0 in the quotient above 7. Now 7 minus 0 is equal to 7. Write 4 in front of 7. Now divide 74 by 36. 36 is a bigger number, whose table is difficult to remember. We can use two methods here. Either start multiplying 36 into 2, 36 into 3 till we get the product as 74 or less than 74. Now 36 into 2 is equal to 72. 36 into 3 is equal to 108. So we will have to consider 36 into 2 is equal to 72, as 72 is less than 74. Or the other method is, consider the first digit on the left of the divisor. 36. It is 3. Now 3 into 2 is equal to 6, which is less than 7 in 74. 3 into 3 is equal to 9, greater than 7 in 74. So we should multiply 36 by 2 and not 36 by 3 to get the product equal to or less than the dividend 74. Now showing the division, we have 36 into 2 is equal to 72. 74 minus 72 is equal to 2. Hence, while dividing 74 by 36, quotient is equal to 2, remainder is equal to 2. Now, let us divide a 3-digit number by a 2-digit number. Let us take an example from exercise 56. Question. Divide. 9. Divide 830 by 18. Solution. Arrange the division vertically. Consider the extreme digit 8 to the left of dividend 830. We cannot divide 8 by the divisor 18. So we write 0 above 8 in quotient. 8 minus 0 is equal to 8. Now write 3 next to 8. Now we have to divide 83 by 18. In table of 18, 18 into 4 is equal to 72. 18 into 5 is equal to 90. Consider 18 into 4 is equal to 72, as 72 is less than 83. Thus, dividing 83 by 18, we get 18 into 4 is equal to 72. Subtracting 72 from 83, we get 11 as remainder. Now write the last digit 0 next to 11. Now divide 110 by 18. In table of 18, 18 into 6 is equal to 108. 18 into 7 is equal to 126. So we have to consider 18 into 6 is equal to 108, as 108 is less than 110. Considering 18 into 6 is equal to 108, we have 110 minus 108 is equal to 2. Thus, 46 is the quotient, remainder is 2. Therefore, answer is, dividing 830 by 18, we get quotient is equal to 46. Remainder is equal to 2. We will now solve an example of dividing a 4-digit number by a 2-digit number from exercise 59. Question. Divide. 3. 9,000 divided by 18. Solution. Arrange the division vertically. The digit to extreme left of 9,000 is 9. 9 is not divisible by 18. So write 0 in the quotient above 9. 9 minus 0 is equal to 9. Write 0 next to 9 now. Divide 90 by 18. 18 into 5 is equal to 90. Now since we get the product exactly is equal to 90, so write 5 in quotient above the line next to 0. 90 minus 90 is equal to 0. Now write the 0 next to 0. 18 into 0 is equal to 0. Thus, answer is when 9000 is divided by 18, quotient is equal to 500. Remainder is equal to 0. Now, let us solve another example from exercise 60. It involves division of 4-digit number by a 2-digit number. Question. Divide 6. 3657 divided by 42. Solution. Write the division vertically. Let us begin with the 2 digits on the left of dividend 3657, that is 36. 36 is less than the divisor 42. So we will consider the 3 digits on the left of the dividend, that is 365. Now let us try 42 into 5 is equal to 210. We have to multiply 42 by a greater number than 5 because 210 is much less than 365. Let us try 42 into 6 is equal to 252. 42 into 7 is equal to 294. 42 into 8 is equal to 336. 42 into 9 is equal to 378. Now we should consider 42 into 8 is equal to 336 because 336 is less than 365. Write 8 above 5 in quotient. Subtract 336 from 365. 365 minus 336. 6 cannot be subtracted from 5. Borrow 1/10 from 6 into units place. Therefore, 15 minus 6 is equal to 9. 6 minus 1 is equal to 5. 5 minus 3 is equal to 2. Therefore, 365 minus 336 is equal to 29. Write 7 next to 29. Now, 42 into 7 is equal to 294. 42 into 8 is equal to 336. So consider 42 into 7 is equal to 294. As 294 is less than 297. 297 minus 294 is equal to 3. Write 7 next to 8 in quotient. We have 3 as the remainder. Thus, 3657 divided by 42 has quotient is equal to 87. Remainder is equal to 3. Let us learn the basic concepts and facts while dividing by 10, 100 and 1000. When a number with 2 or more digits is divided by 10, the units place digit in the dividend forms the remainder. The quotient is equal to number formed by the rest of the digit in the given number taken in same order. When 73 is divided by 10, quotient is equal to 7, remainder is equal to 3. In exercise 61, let us write the quotient and remainder based on this fact. If dividend is equal to 42, divisor is equal to 10, then quotient is equal to 4, remainder is equal to 2. If dividend is equal to 107, divisor is equal to 100, then quotient is equal to 1, remainder is equal to 7. If dividend is equal to 3213, divisor is equal to 1000, then quotient is equal to 3, remainder is equal to 213. If dividend is equal to 83, divisor is equal to 10, then quotient is equal to 8, remainder is equal to 3. If dividend is equal to 612, divisor is equal to 100, then quotient is equal to 6, remainder is equal to 12. If dividend is equal to 6023, divisor is equal to 1000, then quotient is equal to 6, remainder is equal to 023. Let us solve the word problems in exercise 62. Question. Solve the following problems. 1. 105 liters of milk was kept in 7 pots. All the pots hold the same amount of milk. How much milk does each pot hold? Solution. Hint. Since each pot is used, we should divide the total liters of milk by the number of pots. It is given that quantity of milk is equal to 105 liters and number of pots is equal to 7 pots. Since all pots hold same amount of milk and quantity of milk in each pot is to be calculated, we should perform the operation of division. Thus, divide 105 by 7. Arrange the division vertically. Consider the digit on the extreme left of 105, that is 1. 1 cannot be divided by 7, so write 0 in the quotient above 1. Now, 1 minus 0 is equal to 1. Write 0 of 105 next to 1. Now divide 10 by 7. We know that 7 into 1 is equal to 7. 7 into 2 is equal to 14. 14 is greater than 10. So we will have to consider 7 into 1 is equal to 7. Since 7 is less than 10. Divide. Write 1 next to 0 in the quotient above 0 of 105. 10 minus 7 is equal to 3. Write 5 of 105 next to 3. Now divide 35 by 7. We know that 7 into 5 is equal to 35. Hence, write 5 next to 1 in quotient. 35 minus 35 is equal to 0. Thus, when 105 is divided by 7, quotient is 15, remainder is 0. Answer is, each pot holds 15 liters of milk. The most important concept of divisors, that is factors, has to be learnt now. Now let me explain the term factor. Let us take an example. If 3 is a factor of 15, how do you find that out? Remember, to find the factor, you have to know your tables thoroughly. Is 15 there in table of 3? Now, 3 into 5 is equal to 15. Hence, 3 is a factor of 15. What do we conclude from this simple example? We can conclude that if the dividend is there in the table of the divisor, then the divisor is a factor of the dividend. Let us take another example. Is 3 a factor of 17? Here, 3 is the divisor, 17 is the dividend. Is 17 there in table of 3? 3 into 5 is equal to 15. 3 into 6 is equal to 18. Thus, 17 is not there in the 3 times table. Thus, 3 is not a factor of 17. In bigger numbers, we cannot say if the dividend is there in the table of the divisor or not. Then we have to actually divide the dividend by the divisor to find out if the divisor is a factor or not. Say for example, is 3 a factor of 42? Let us divide to find out. Consider the digit 4 to left of dividend 42. Now, 3 into 1 is equal to 3, which is less than 4. 3 into 2 is equal to 6, which is greater than 4. So consider 3 into 1 is equal to 3. Write 1 in quotient above the line. 4 minus 3 is equal to 1. Write 2 of 42 next to 1. Now, 3 into 4 is equal to 12. Write 4 in quotient next to 1. 12 minus 12 is equal to 0. Thus, remainder is equal to 0. Quotient is equal to 14. Hence, we can say that since 3 divides 42 completely, it is a factor of 42. Similarly, if we divide 49 by 3, it will not be completely divided by 3. We get remainder as 1. Quotient as 16. So 3 is not a factor of 49. Let us see these examples. 11 is equal to 1 into 11. 15 is equal to 1 into 15. 105 is equal to 1 into 105. 309 is equal to 1 into 309. 47 is equal to 1 into 47. Thus, from above examples, we can determine that every number has 1 and the number itself as its factors. Note that we have not written other factors of above numbers. Remember, a number can have more than one factor, as it can occur in many tables. Say for example, write all factors of 12. We know that 1 into 12 is equal to 12. In table of 2, 2 into 6 is equal to 12. In table of 3, 3 into 4 is equal to 12. Next, 4 into 3 is equal to 12. Do not repeat it, as we have already written 3 into 4 is equal to 12. Thus, now to write the factors of 12, write all the numbers we multiplied. Thus, factors of 12 is equal to 1, 2, 3, 4, 6, 12. Let us solve other examples from exercise 63. Question 1. Write all factors of 32. Now, 1 into 32 is equal to 32. In 2's table, 2 into 16 is equal to 32. In 3's table, we do not have 32 because 3 into 10 is equal to 30 and 3 into 11 is equal to 33. Therefore, 3 is not a factor of 32. Next, in table of 4, 4 into 8 is equal to 32. Again, in 5, 6, 7 tables, we do not get 32. In table of 8, 8 into 4 is equal to 32 is repeated. So, we stop at 4 into 8 is equal to 32. Let us look at the factors of 32 clearly, not considering 3 as a factor. Therefore, we have 1 into 32 is equal to 32. 2 into 16 is equal to 32. 4 into 8 is equal to 32. Thus, answer is factors of 32 are 1, 2, 4, 8, 16 and 32. Question 2. Circle those of the following numbers which are factors of 60. 8, 4, 5, 11, 12, 15, 10, 14. Solution. divide 60 by 8. In table of 8, 8 into 7 is equal to 56. 8 into 8 is equal to 64. So by dividing 60 by 8, we get remainder as 4 and quotient as 7. As 60 cannot be completely divided by 8, so 8 is not a factor of 60. In table of 4, 4 into 15 is equal to 60. Hence, 4 is a factor of 60. In table of 5, 5 into 12 is equal to 60. Hence, 5 is a factor of 60. In table of 11, 60 is not there. Hence, 11 is not a factor of 60. In table of 12, 12 into 5 is equal to 60. Hence, 12 is a factor of 60. 15 into 4 is equal to 60. Therefore, 15 is a factor of 60. 10 into 6 is equal to 60. Therefore, 10 is a factor. In table of 14, we do not have 60. Hence, among the given numbers, factors of 60 are circled. See 4, 5, 12, 15 and 10. Question 3. Write two numbers such that both 3 and 7 are among their factors. Solution. 3 into 7 is equal to 21 and 7 into 3 is equal to 21. So, 21 is one of the numbers whose factors are both 3 and 7. Now, hint. 21 into 2 is equal to 42. 3 into 14 is equal to 42. 7 into 6 is equal to 42. Hence, 42 is another number whose factors are 3 and 7 similarly. 42 into 2 is equal to 84. And 3 into 28 is equal to 84. 7 into 12 is equal to 84. Hence, 84 will be the number whose factors are 3 and 7 and so on. Hence, answer is two numbers whose factors are both 3 and 7 are 21, 42. Now, let us understand the concept of dividend and multiple. Let us understand with the help of examples. When we divide 15 by 3, 3 into 5 is equal to 15. Quotient is 5. We do not have any remainder. But when we divide 17 by 3, the quotient is 5. Remainder is 2. Hence, 15 is divisible by 3, but 17 is not divisible by 3. Hence, all numbers which are divisible by 3 without getting a remainder will be multiples of 3. That is, all numbers occurring in table of 3 are its multiples. Thus, 3, 6, 9, 12, 15, 18, etc. are all multiples of 3. Thus, to find multiples of any number, keep adding the number to it to get all its multiples. To know whether a given number is a multiple of some numbers, divide that number and find out. For example, let us solve the exercise 64 to understand this clearly. Exercise 64, question 1. Which of the following numbers are multiples of 6? Circle those. 18, 30, 46, 52, 78, 120. Solution. 6 into 3 is equal to 18. Therefore, 18 is a multiple of 6. 6 into 5 is equal to 30. Therefore, 30 is a multiple of 6. 46 does not occur in table of 6. Therefore, 46 is not a multiple of 6. That is, it cannot be divided by 6. 52 do not occur in table of 6. Therefore, 52 cannot be divided by 6. Hence, 52 is not a multiple of 6. Divide 78 by 6. While dividing 78 by 6, quotient is equal to 13. Remainder is equal to 0. Hence, 78 is a multiple of 6. Divide 120 by 6. While dividing 120 by 6, quotient is equal to 20. Remainder is equal to 0. 120 divided by 6, quotient is equal to 20. Remainder is equal to 0. 120 is a multiple of 6. Hence, answer is multiples of 6 among the given numbers are 18, 30, 78 and 120. 3. Write 5 multiples of 7. Solution. Add 7 to itself 5 times. That is, recollect table of 7. 7 into 1 is equal to 7. 7 into 2 is equal to 14. 7 into 3 is equal to 21. 7 into 4 is equal to 28. 7 into 5 is equal to 35. Thus, 5 multiples of 7 are 7, 14, 21, 28 and 35. Question 4. Write any 5 numbers which are multiples of both 2 and 5. Solution. Here we have to recollect the test of divisibility of 2 and 5. Test of divisibility of 2. If digit in units place of number is 0, 2, 4, 6 or 8, then that number is divisible by 2. Test of divisibility of 5. If digit in units place is either 0 or 5, that number is divisible by 5. So, in table of 2, whenever we get number with 0 in units place will also be multiple of 5. Because in table of 2, we do not get 5 in units place of any number. Thus, 2 into 5 is equal to 10. 2 into 10 is equal to 20. 2 into 15 is equal to 30. 2 into 20 is equal to 40. 2 into 25 is equal to 50. Now, 10, 20, 30, 40, 50 are also multiples of 5. Hence, answer is 5 numbers which are multiples of both 2 and 5 are 10, 20, 30, 40, 50. 6. Of which of the following numbers is 544 a multiple? 5, 4, 6, 7, 9, 2. Find out by dividing. Solution. Dividing 544 by 5, we cannot divide 544 completely by 5 because quotient is equal to 108. Remainder is equal to 4. 544 is not a multiple of 5. 544 divided by 4, quotient is equal to 136. Remainder is equal to 0. 544 is a multiple of 4. 544 divided by 6. Quotient is equal to 90. Remainder is equal to 4. 544 is not a multiple of 6. 544 divided by 7. Quotient is equal to 77. Remainder is equal to 5. 544 is not a multiple of 7. 544 divided by 9. Quotient is equal to 60. remainder is equal to 4. 544 is not a multiple of 9. 544 divided by 2, quotient is equal to 272. Remainder is equal to 0. 544 is a multiple of 2. 5. Write any three numbers which are multiples of 2 but not of 3. Solution. Write tables of 2 and 3 side by side. 2 into 1 is equal to 2, 2 into 2 is equal to 4, 2 into 3 is equal to 6, 2 into 4 is equal to 8, 2 into 5 is equal to 10, 2 into 6 is equal to 12, 2 into 7 is equal to 14, 2 into 8 is equal to 16, 2 into 9 is equal to 18, 2 into 10 is equal to 20. 3 into 1 is equal to 3, 3 into 2 is equal to 6, 3 into 3 is equal to 9, 3 into 4 is equal to 12, 3 into 5 is equal to 15, 3 into 6 is equal to 18, 3 into 7 is equal to 21, 3 into 8 is equal to 24, 3 into 9 is equal to 27, 3 into 10 is equal to 30. Now, pick out the common products from both tables of 2 and 3. They are 6, 12, 18. Thus, do not consider these three numbers 6, 12, 18, which are multiples of 2 and 3 both. So now, the numbers other than 6, 12 and 18 which occur in table of 2 but not in table of 3 are the required numbers. Thus, answer is 4, 8, 10, 14, 16 and 20, etc. are the numbers which are multiples of 2 but not of 3.